Hi, this lesson is about solving quadratic equations by factoring. In order to solve a quadratic equation by factoring, the equation must be in standard form. This is what it means for it to be in standard form. It means that your terms are all separated by either pluses or minus signs, and all the terms are on one side and the other side of the equation is zero. The part of this equation that makes it a quadratic is this part right here, the degree of 2. So a second degree polynomial on one side of the equation is why we call it a quadratic equation. When we factor these quadratic equations in order to solve it, we will also be using the zero product rule. The zero product rule says that if two expressions are multiplied together, we're calling those expressions A and B, and they equal 0, then that means that A must equal 0 or B must equal 0, or possibly both. So let's do a few examples and see how this works. So here's our first example. We have x plus 3 times x minus 4 equals 0. So this is not an equation in standard form, but it is already factored for you. So you can go ahead and use the zero product rule, which says that the first factor, x plus 3 equals 0, and the second factor, x minus 4, also equals 0. Those factors are linear equations, so all you have to do is move the constant over to the other side by doing the opposite operation. Here you subtract 3, you get that x is negative 3. Here you add 4, and you get that x is 4. So there are two solutions to this equation, x equal to negative 3 and x equal to 4. It is often the case that with quadratic equations, you will get two solutions. So here's another example. X squared minus 5x minus 6. This equation is in standard form. All the terms are on one side of the equation. We have to factor. So we're looking for two numbers that multiply together to give me negative 6, but when you add them, you get negative 5, which means you'll be subtracting because one must be positive and one must be negative in order to have a negative 6 here. So what will work? Negative 6 and positive 1. So my factors are x minus 6 and x plus 1. When you set each factor equal to 0, as I did in the previous example, you get that x equals 6 and x equals negative 1. Again, two solutions. So here's another one. Y squared plus 4y equals 5. This equation is not in standard form because my y terms or my variable terms are on one side and the other side has the constant. I need the whole thing set equal to 0. So in the second line, I subtract 5 from both sides, leaving me with y squared plus 4y minus 5 equal to 0. That's now in standard form. So now I can factor. So I'm looking for two numbers that multiply together to give me negative 5, but when you add them, you get a 4. So that will be 5 and negative 1. So my factors are y plus 5 and y minus 1. Set each factor equal to 0, and you get that y is equal to negative 5 and y is equal to 1. So just like other equations we've done in the past, whenever you get a solution, if you plug the solutions back into the original equation, if the left side equals the right side, then you know you did it correctly. And so far, all the ones we did work. So here's number 4. Number 4 says 2x squared equals negative 7x minus 3. Again, this is not in standard form. I like to keep my first term or the x squared term positive. So I'm going to add 7x and add 3 over to the left side, which is what you see right here. And now my equation is in standard form. So this is a trinomial with a leading coefficient of 2. Remember, we talked about two ways to factor these, either by trial and error or the AC method. So I did it by trial and error, but you can certainly do it by AC method if you prefer that. So in the first position, I need a 2x and an x to get 2x squared. And in the second position, I need either 1 and 3 or 3 and 1. So I put 1 here and 3 here. And the reason that works is because my outer is 6x, my inner is 1x, and 6 plus 1 gives me 7x. If you had put the 3 and the 1 in different positions, it would not work out. You wouldn't get the middle term, so your factoring would be incorrect. Then you set each factor equal to 0, so that's what you see here. For the first one, 2x plus 1 equals 0. Subtract 1 and then divide by 2. You get that x is equal to negative a half. And then for the second one, you subtract 3. So you get x is equal to negative 3. Again, two solutions for this quadratic equation. All right, so let's move on to number 5. That's here on the right. So I have y times y minus 2 equals 63. Again, this is not in standard form, but there's a little bit more work to do. On the left, you need to distribute. So you get y squared minus 2y. And then you need to subtract 63 so that it moves over to the left side. So I get y squared minus 2y minus 63 equals 0. Now you need two numbers that multiply together to give you negative 63. When you add them, you get negative 2. Again, that means you have different signs. So what will work? Negative 9 and positive 7. So we get y minus 9, y plus 7. Then set each factor equal to 0. You get that y is equal to 9 and y is equal to negative 7. All right, so here's another example. This one definitely does not look like a quadratic equation. Notice it is a third degree polynomial, but we can still solve this in a similar way by factoring. So the first thing I notice is that 9t cubed and 81t have a common factor, a greatest common factor of 9t. So first factor out 9t. That leaves me with t squared minus 9. Then t squared minus 9 is the difference of perfect squares. So when I factor that, I get t plus 3 and t minus 3. What that means is that when I now solve this equation, I have to solve 3 factors set equal to 0, which is what you see on this line. I have 9t equals 0, t plus 3 equals 0, and t minus 3 equals 0. So 9t equal to 0 divided by 9, you get that t is equal to 0. Then subtract 3 from t plus 3, you get t is equal to negative 3. And finally, you get the answer of t equal to 3. So it is common for you to have the same number of solutions as the degree. So I had a third degree polynomial. I got 3 solutions. There are exceptions, and that's when you have the same solution repeated. But if you don't have any repetitions, you get solutions that correspond with the degree. All right, here's one last problem. I have 8t squared equals 16t. Again, this is not in standard form, although it is a quadratic equation. When I put it in standard form, I get 8t squared minus 16t plus equals 0. Remember that when I first started this lesson, I said standard form looks like this. So here I'm missing the constant. I have the variable squared, then I have the variable with a coefficient, but I don't have a constant. That's okay. As long as you have the squared variable in your expression, that's considered to be a quadratic equation. Okay, so now I have to factor this. So this factors, again, there's a GCF of 8t, factor that out, leaving me with 8t times t minus 2. Then set each factor equal to 0. 8t equals 0 and t minus 2 equals 0. So you get that t is equal to 0 and t is equal to 2. Again, 2 solutions for this equation. Okay, the second part of this lesson is regarding word problems that will result in a quadratic equation. So we'll be using the techniques that we practiced just recently in the past few examples to solve these word problems. The word problems will be based off of shapes, either a rectangle or a triangle. So let's look at the first example. The length of a rectangle is 1 inch more than twice the width. The area of the rectangle is 36 inches. Find the length and the width. Okay, so you're told something about the length. You're told the length is 1 inch more than twice the width. So that means the variable the dimension that I know nothing about is the width. So that's the one I'm going to assign a variable to. I'm going to call it W. You could call it X if you prefer, or really any letter you like. Now I need to express the length in terms of the width. So again, using this statement right here, 1 inch more, that's the plus 1 part, then twice the width, that's 2 times the width. So the length is 2W plus 1. Okay, so remember, you might remember this from when you took geometry, that length times width equals area. So now we plug in what we know. Our length is 2W plus 1. Our width is W. So 2W plus 1 times W equals, and again, the area is given as 36. All right, so now I need to solve this equation. So on the left, I'm going to distribute, and that gives me 2W squared plus W equals 36. Once I distribute, you can see that I have a quadratic equation because of 2W squared, which means you must set it equal to 0. So in order to set it equal to 0, I'm going to subtract 36. So I have 2W squared plus W minus 36 equals 0. All right, I will use AC method here. So AC would be 2 times negative 36. That gives me a result of negative 72. So now I need two numbers that multiply together to give me negative 72. But when you subtract them, because they'll be opposite signs, you get a 1 because the coefficient of W is 1. So what will work? 9 and negative 8. Because 9 minus 8 is 1. Okay, so now we take the 9 and the 8, and we use that to rewrite the middle term. And that's what I did right here. I have 2W squared plus 9W minus 8W minus 36 equals 0. Remember that 9W minus 8W is just W, which is the middle term. So we're just taking the equation and rewriting it in a different way. Now we can factor by grouping. Factor by grouping means that we factor out the GCF of each pair of the terms. So in other words, the first two, 2W squared plus 9W, have a common factor of W, leaving me with 2W plus 9. And the second two have a common factor of minus 4, leaving me with 2W plus 9. Since 2W plus 9 is the common binomial, you can factor that out, and that's what you see on this line. And then what's left is W minus 4. So my factors are 2W plus 9 times W minus 4. Now we take each factor, set it equal to 0. That's what you see here. Solve them, and your first answer is that W is negative 9 halves. I put a line through it because you cannot possibly have a negative dimension. You cannot have a negative width on a rectangle, so that is an impossible solution to this problem. But here we get W is equal to 4. You can certainly have a length of 4, or a width of 4. Now I need to find what the length is. Remember, the length is 2W plus 1, which is what you see right here. 2 times 4 plus 1, which gives me an answer of 9. So the width of the rectangle is 4 inches and the length is 9. Okay, so let's do another. This is another one regarding a rectangle. It says the length of a rectangle is 4 inches more than twice its width. Its area is 96 inches squared. Find the width and the length of the rectangle. So, similar to the last problem, we are told something about the length, but we know nothing about the width. Therefore, W is my variable. How do I express length in terms of width? Well, the length is 4 inches more, again there's that more, is plus, than twice the width, 2 times the width. Here's our formula. Length times width equals area. You're told that the area is 96 inches squared. That's given in the problem. All right, so now we have to plug in what the length is. 2w plus 4 times w equals 96. Now we distribute on the left. That gives us 2w squared plus 4w equals 96. Again, set it equal to 0, so it needs to be in standard form. So that's what you see on this line. But before we start factoring by using AC method like we did in the last example, at this point, it has a common factor of 2. So that's what I did from this line to this. I factored out a 2. That will make our trinomial easier to factor. So when you factor out a 2, you need to now factor w squared plus 2w minus 48. So here we're looking for two numbers that give me a product of negative 48, but when we add them or subtract, because they will be different signs, you get 2. So what will work? 8 and negative 6. So we get 2 times w plus 8 times w minus 6. Take each factor, set it equal to 0, and we get that. And by the way, you wouldn't want to do this. This wouldn't make sense. You can ignore the 2 at this point. 2 does not equal 0. W would equal negative 8, and W would equal 6. Again, ignore the negative 8. You can't have a negative dimension. When your width is 6, your length is, remember, length is 2W plus 4, so that is 16. So we have a width of 6 inches and a length of 16 inches. Okay, last example is about a triangle. It says the area of a triangle is 36 feet squared. The height is 1 foot shorter than the base. And we want to find the base length and the height. So we need to find, for B and H, those are the variables I'm using. So we know something about the height. The height is 1 foot shorter than the base. So I'm going to let B be my base, the one I know nothing about. And we express H, 1 foot shorter would be H equals B minus 1. Okay, the area of a triangle is 1/2 base times height. So that's what you see here. So it's 1/2 B times B minus 1 equals 36. Okay, so on the left, I distributed the B. So I have 1/2 B squared minus B. And then in the next line, I want to get rid of that 1/2. So I'm going to multiply both sides by 2. When I do, the 2 and the 1/2 will cancel on the left. And on the right, the number becomes 72. So now we subtract 72 in order to put it in standard form. So I get B squared minus B minus 72 equals 0. Now I'm looking for two numbers that multiply together to give me negative 72. But when I add them, I get negative 1 because of the coefficient here. And so negative 9 and 8 will work. Here you get that B is equal to 9 or B is equal to negative 8. Again, you can ignore the negative 8. You cannot have a negative dimension. So if the base is 9, your height is B minus 1. So your height is your height H is equal to 8. So your answers are that the triangle has a base of 9 feet and a height of 8 feet. Okay, so that's the lesson. So give the homework a try. Good luck.